today by asking a pretty serious question. Why do so many incredibly talented engineering teams still let manual database management completely throttle their application's true potential? I mean, we've all been there, right? You're building the future of a product, only to be totally held back by the fragile, high-maintenance infrastructure of the past. It's frustrating. Today, we're going to fix that. Welcome to Architecting for Scale with Cloud SQL. We're taking a deep, cinematic dive into enterprise-grade cloud database infrastructure and figuring out exactly how to build for massive scale. Okay, let's dive into this. Picture the gritty reality of on-premise self-managed databases. You know the scene. It's late at night, the hardware is totally overloaded, performance has just ground to an absolute halt, and your developers are furiously troubleshooting instead of, actually sleeping. And database crashes? They don't just mean tired engineers. They mean direct revenue loss, incredibly frustrated users, and massive reputational damage to your business. Section 1, the cloud solution. Meet Cloud SQL. There is a much better, way calmer way to operate. Let's step out of that noisy physical server room and up into the cloud. Cloud SQL is Google Cloud's fully managed database service, and it's designed specifically to let Google handle all the heavy infrastructure lifting. That way, your team can focus on what actually matters, which is your application. It takes the three most popular relational database engines on the planet, Postgres, MySQL, and SQL Server, and serves them up as a fully managed service. So, all those wildly time-consuming tasks, database provisioning, automated backups, storage capacity management, yeah, they're handled for you right out of the box. You get to keep full compatibility with your existing apps, just without the operational headache. It's almost like magic. New database instances just spin up seamlessly, right on demand. You don't have to spend weeks estimating server capacity anymore, or even worse, buying ridiculously expensive hardware that you might not even fully use. You just deploy exactly what you need, exactly when you need it. It completely eliminates all the guesswork from hardware sizing. Now, what's really interesting about this slide is this massive number right here, 64 terabytes. If your available storage drops below a certain threshold, Cloud SQL can actually automatically and dynamically add storage capacity all the way up to 64 terabytes. And the absolute best part, it does this with zero downtime. None. Your database simply grows as your application demands it. It literally prevents those nightmare out-of-space outages without you having to lift a single finger. Section 2, Architecture, Availability and Scaling. Let's transition into the technical core of this architecture. I want to show you exactly how Cloud SQL handles massive traffic securely and protects your critical data against those unexpected outages. So here's the step-by-step process of Cloud SQL's high availability or HA configuration. If a zone goes down and your primary instance fails, Cloud SQL automatically detects the failure and switches your application straight over to a standby instance. And because of how the data is synchronously mirrored, this gives you a recovery point objective, or RPO, of exactly 0. That means absolutely zero data loss during a zonal failure. Pretty incredible, right? To actually make that possible, the high availability setup uses a regional persistent disk to synchronously replicate your data across different zones. So when that automatic failover kicks in, your application is back up and running fast. We're talking about a recovery time objective of roughly a single minute. That keeps your business online and your users happy, even when the underlying physical hardware completely fails. But what about application performance or larger-scale regional disasters? Well, that's where asynchronous read replicas come into play. You can easily route all of your heavy read traffic over to these dedicated replicas, which keeps your primary instance perfectly stable for all your critical write operations. Plus, you can deploy these replicas across entirely different geographic regions. So if an entire region goes completely dark, worst case scenario, you can just promote a cross-region replica to become your new primary instance and keep your global application humming along. Section 3, Choosing Your Edition. Of course, not every application needs the exact same level of firepower. So how do cloud architects actually choose the right tool for their specific workload? Well, Cloud SQL offers two distinct editions. The Enterprise Edition is absolutely fantastic for general applications, giving you a really solid, highly reliable architecture. But if you're running highly demanding, mission-critical workloads, you're definitely going to want the Enterprise Plus Edition. Enterprise Plus unlocks some serious enhanced hardware. We're talking scaling all the way up to 128 vCPUs and 824 gigabytes of RAM. It also introduces data caching for insanely fast reads and lets you scale your instances with sub-second downtime.
But the absolute standout metric for the Enterprise Plus edition is this massive 99.99% availability SLA. And what makes this truly exceptional is that this SLA uniquely includes planned maintenance. Yep, you heard that right. That means even when Google is applying software patches or upgrading the underlying hardware in the background, your database remains highly available to your users. It's a real game changer.
Section 4. The Google Cloud Database Ecosystem. Now, to truly master cloud architecture, we really need to contextualize Cloud SQL alongside Google Cloud's other heavyweight database offerings. That way, you'll always know exactly which tool to reach for. And this brilliantly illustrates the difference. Cloud SQL is your go-to for general-purpose frameworks, things like your CRMs, ERPs, and standard e-commerce platforms. But say, you're building a global financial ledger or a massive multiplayer game that requires literally limitless horizontal scale and a mind-bending 99.999% availability. For that, you'd step up to Cloud Spanner. Spanner gives you that relational, strongly consistent structure, but with the massive global scale that's usually only reserved for non-relational databases. Alternatively, if you're strictly focused on PostgreSQL but you need extreme, uncompromising performance, you'd look at AlloyDB. See, while Cloud SQL perfectly manages standard open-source engines, AlloyDB takes PostgreSQL and completely supercharges it. It's built for the most demanding enterprise workloads, delivering speeds up to 4 times faster for transactional queries and an astonishing 100 times faster for analytical queries. It even comes complete with machine learning autopilot systems. It's a beast. Section 5. Security and Best Practices. Now, with all this incredible scaling power right at our fingertips, we absolutely must implement some critical guardrails. Because, let's be honest, a powerful cloud infrastructure is a massive liability if it isn't completely secure. According to our sources, improper identity and access management, or IAM configurations, are actually among the most serious security risks in the cloud. Organizations so often grant way too many permissions just for the sake of convenience. To avoid a catastrophic breach, you have to strictly enforce the principle of least privilege. You need to use role-based access control, always enable multi-factor authentication, and conduct regular permission reviews. Basically, lock it down. Give users only what they absolutely need to do their jobs and nothing more. Section 6. The ultimate business impact. Let's zoom back out from all the deep technical details, the failover mechanics, and the IAM policies, and talk about the overarching business value here. Why do we go through all the effort of architecting this? So the crucial point is this. Leveraging a managed service like Cloud SQL isn't just a simple technical upgrade. It's a profound business strategy. It translates directly to lower operational costs, significantly faster and way more reliable applications, and perhaps most importantly, incredibly happy engineering teams. When your developers aren't wasting their late nights patching servers and desperately configuring backups, they're free to build the features that actually drive your business forward. Which brings us to our final thought. I want you to ask yourself honestly, is your team building the future, or are they just managing the infrastructure beneath it? It might be time to rethink your architecture, offload that heavy lifting to the cloud, and truly unlock your application's potential. Thank you so much for joining me on this explainer, and I really hope this helps you build faster, smarter, and way more securely.